everyone. My name is Caroline Richardson and welcome to Make the Grade. For those of you who have never been here, I am here to answer your math questions. There's going to be a number that's going to go across the bottom of your screen. Or look right there, see the bottom of your screen. And you call in on that number, and if you're having trouble with any of your math, or you have questions, and maybe you don't have a specific problem in your homework that you want me to go over, or just a concept that you're not sure, or parents, maybe you're working with your child on homework and you're not quite sure what to do. Just give me a call and I will give you some guidelines for it. And then you can go back and you can watch it on your television set, or, which of course since you're seeing me now, it's on the television set. If you look here on my screen, we also are live on the web. So if there's some Wednesday afternoon and you're not near a TV, you can go to http://EWTV, which stands for eastwaketv.org. Go there and it'll ask you whether you want to do a live link or a dial-up, and then you'll find the show, okay? And here is the phone number, 217-2203. Just give me a call, and I'll answer your questions. And then finally, if you have questions throughout the week, I have a website that you can go to, mathhelp@wcpss.net, for Wake County Public School System.net. Just email me, and I check it I check it almost every day, but then I check it right before I come to the show. So if you have a question, just let me know. All right, well today we're going to get started. The EOGs are coming, the EOCs are coming, everything's right around the corner, the end of the year is coming, right? I know you're excited, but that doesn't mean you stop, right? You still have a good solid month. Those of you on block scheduling, 1 month is kind of 2 months, right? So you can't let go and just kind of pretend like nothing's going on. And middle school, you're starting to wrap up and you're probably starting to practice your EOGs right now. So what we're going to do is I'm going to start today with some practice problems on the EOG, and I want to talk a little bit about testing strategies and sometimes how those trick questions come up and things that you need to look for, okay? All right, let's get started with this first one. And I'll zoom in a little bit so you can see it, and then I promise I'll get these bigger for you, okay? Woo! Isn't that cool? It's very cool. All right, this is samples coming from the 6th grade EOG. Do you have the goal? And this is coming from goal 1, which I will tell you what that is in a minute. And the statement, here we go. Make sure that you guys, everybody knows what we're working on. Goal 1, this is objective 1, develop number sense for negative rational numbers, okay? Connect the model, number, word, and number using a variety of representations, including the number line. Compare and order, make estimates in appropriate situations. All right, so this is dealing with our real and rational numbers and our integers and trying to order them and make sure that we understand how they all fit together. So look at this first one. Which statement is true? Now I strongly recommend on the EOC or EOG or any standardized test you're taking, especially in math, I want you to look at the question very carefully before you start looking at all those answers. The question says which statement is true. So if there's 4 answers, 1 is true and the other 3 are false, okay? So if we look at it now, which statement is 2? 2 is greater than negative 2. 2 is less than negative 4. Negative 2 is less than negative 4. Negative 4 is greater than 4. Sometimes these get very confusing. So what I would do is I would draw a number line, and I would plot some of these points. Let's go ahead and put 0 in. Here's 2. Here's negative 2. Make it big enough. There's 3. There's positive 4. There's negative 3, and there's negative 4. If you can see it visually, it might be a little bit easier for you to understand the statement. The first one says, is 2 greater than negative 2? So is 2 greater than negative 2? Well, if it's further to the right, then it's greater, isn't it? So that looks pretty good. That looks right. Well, let's just double check the other ones to be sure. Is 2 less than negative 4? 2 less than negative 4? Well, no, it's further to the right, so it's greater. So that's how we know B is wrong. Is negative 2 less than negative 4? And you have to be careful with your negatives. Okay, it appears like if we took the absolute value of 2, 2 seems to be bigger than 4, but if we were talking how much money you owed me, would you rather owe me $2 or owe me $4, okay? So, and the farther it is to the left of the number line, the smaller the number. So that one's not true either. And then negative 4, is that greater than positive 4? Definitely not. It's further to the left, so it would have been less than. All right? Now, if you're pressed for time, as soon as you found one of them to be right, you know that you're done, and you found it. But I would go ahead and take the time to be sure that you have all the answers correct. So the answer to this one is A. All right, let's look at, I'm going to have to back up just a little bit. There we go. Hopefully you can read that. Whoa. Okay. On which number line does the letter n represent the integer -1? All right, so we have 4 different number lines. The letter n, it looks like all of them have been labeled n, so there's no tricks. Be very careful in case they've labeled other points on there. Represented by the integer. Remember what your integers are? Okay, integers. Let's just do a quick reminder. In fact, let me grab another piece of paper. Quick reminder of your sets. You have your natural numbers. What are your natural numbers? Good, I heard you out there. Your natural numbers are as if you were counting, like sometimes they're called the counting numbers. 1, 2, 3, and they go on forever, okay? Then comes your whole numbers. There's one big difference between natural numbers and whole numbers, and that big difference is, what's a hole in the ground look like? A 0, you're right. So if you tag 0 and add that to the natural numbers, there's your whole numbers, the whole, see? All right, then come your integers. Integers. The integers are your whole numbers, 0, 1, 2, 3, and so on, and they're opposites, okay? So I need you to picture the number line. 0 doesn't have an opposite, but the opposite of 1 would be -1. Okay? The opposite of 2 would be -2. The opposite of 3 would be -3, and so on, okay? All right, so we're looking for integers, so that means there's no decimals and fractions. The next set that has some of your fractions and decimals, and I'll come back and talk about that in a minute, would be, well, we're right here. We might as well talk about it now, so I have to go wider so you can see. Surprise! Rational numbers there at the bottom. Rational numbers might have been explained to you several different ways. The official definition is any number that can being the operative word, be expressed in the form A over B. Now that's a good review for you Algebra 1, Geometry, and Algebra 2. 6th grade, you may or may not have seen it that way. One of the ways you might have seen it is a number that terminates or repeats when you do the division. So for example, if I gave you the number 2/5 and I did that division, I would say 5 divided into 2. You have to tack on the 0, so that would be 0.4. See how that number terminates or stops? That would be an example of a rational number. And the number 5 is a rational number. It also happens to be an integer and a whole number and a natural number, but it can be written as 5/1. So the idea is numbers that can be written as fractions. All right, so those are where your fractions and decimals are. All right, so let's come back over here to our problem. And I'm going to take the time to do some of that because you all need to be sure that you understand the way the questions are being worded to you, okay? So on which number line does the letter n represent the integer -1? So if we look at this, here's 3. Go ahead and put in the other numbers. There's 2, there's 1, there's -1, so A did not work. All right, does n work? Is n represented by -1 here? There's 2, there's 0, there's -1, so B does not work. Is this n -1? So there's 0, so there's 1, here's -1, 2, -2, that one doesn't work. So D better work, otherwise we made an error in what we were trying to find, right? So here's 0, or here's 1, here's 0, there's -1. And sure enough, that point has the coordinate -1 and the point n. So D is our answer. Okay. And finally, let's look at this third one. There we go, if you can see that. In the table below, which city has the coldest average temperature for November? Coldest, okay? So I need you to think about what makes things cold. Okay, so let's draw what's going to be a very sad thermometer, okay? And in the thermometer, there's mercury, if you've seen a thermometer like that. And freezing would be 32 degrees Fahrenheit or 0 degrees Celsius, okay? So now let's look at these numbers. In city P, negative 13. Well, negative 13 would definitely be, here's 0 degrees Fahrenheit. So here's negative 13 degrees Fahrenheit. And 59 degrees Fahrenheit, well, that would be maybe up here, 59 degrees Fahrenheit. And that's city Q. Negative 13 was city P. City R is negative 15, so negative 12, negative 13, negative 14, negative 15. That would be below, oops, that would be below city P, so that is city R. And then 32 degrees, well, there it is right here. I'd already labeled that one, happens to be city S. So you guys, look at this. This thermometer is nothing more than, dun, 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 dun. Uh-oh, I have to go this way. Dun, 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 dun. It's nothing more than a number line. There's 0 to the right, which was going up the thermometer, are your positive numbers, and to the left, or going down the thermometer, are your negative numbers. So the question is which is the coldest? Well, you need to know that the lower the temperature on a thermometer, the colder it is. So it looks to me like that's the lowest, which would make that the coldest, so that's city R, which is option C. Okay? Awesome. All right. So it's coming. It's coming. EOG, you can do it. Okay? You just need to take your time with the problems. I mean, be aware of your time. Take your time and make sure you understand what the question's asking you. Your teachers can't help you once that test starts, so you need to look at the question carefully, underline the things that are important, and look at each answer. Okay? All right, we just got a call from Megan in Knightdale High School, Algebra 1 class, and she wants to know, can we solve this problem, this system, by graphing? Yes, we can, Megan. And this is, I heard from your teachers that you all are working on systems of equations. So before I graph it for you, let me talk just a little bit about systems in case anybody else is going to call it the system. Okay, let me zoom out just a little bit. Of course, it's hard to tell when I have nothing on the paper. All right, let's talk about systems of equations. Can we see that? Systems of equations. What is a system of equations? Well, a system, in this case, is going to mean more than one. And the problem that Megan just gave us, she gave me 2 equations. So we'll be working, this problem that we'll be working on will be a system of 2 equations. In a system of equations, what you're looking for is how do those 2 equations communicate with each other. Okay? So there's 2 ways systems can occur. Now the other thing, before I even talk about that, come back to me. The other thing we need to talk about is what do they represent? Mathematicians can make an equation out of anything. In fact, some of the latest technology they've been talking about, as people walk into a building and how cameras, can videotape you when you walk into, say, the mall or something, they actually have a program now that can take your face and make equations out of your face. So your face would have an equation. Might be a very complicated equation, but it's an equation that would map it back to the coordinate system. All right, so you have all this data, the data comes together, you make an equation out of it. That way it's represented. Once you have it represented numerically, either from the graph, or if you had it represented numerically, then you could put it onto the graph, correct? You all have equations like the one she gave me, y equals 1/2 x plus 1. You could take that and substitute in values for x and y and plot it on a coordinate system, right? Graphically. Well, think about if you had 2 equations. I said we're doing a system. If you had 2 equations, how those 2 equations might exist in the real world, okay? So here's an equation. These are linear equations, so it's a line, okay? So maybe they represent an airplane. Well, what's going to happen if you have 2 airplanes, okay? If you have 2 airplanes flying at the same level, what's going to happen to them? They could intersect, right? So in a system of equations, one of the things you're trying to determine is what is the common point of intersection. If they have a common point of intersection, okay, in this case of the planes, that wouldn't be good. And say the computer comes up with that you've got 2 planes on the same path and they're going to come up with a common equation or common answer for their equations, then what would you want to do? You'd want to tell one of those planes to rise up or lower down or change its course, correct? All right, so that's where systems of equations are going to be used in real life. So think about the ways that they could happen. Now, you could also have 2 planes taking off from, let's say, Raleigh to New York, and then another one takes off Raleigh to New York, and maybe it's going faster and they catch up with each other, right? Well, they would be parallel to each other. So it's very possible that you could have 2 paths, like a train. Okay, 2 trains can be running parallel to each other. We want them to run parallel. We don't want them to run into each other. And the third would be, what if they're right behind each other? Okay, so there goes one train and there comes the other train, like all the cars that are attached to it. They're basically the same equation. Okay, so if we look at the coordinate system, our equations can intersect somewhere. They can not intersect at all and be parallel, or they could be the same line and exist together. Now, when we talk about the algebra, if the two equations, the graphs of the two equations intersect at this one point, then that means there's one solution. If the two lines are parallel, that would mean that there are no solutions. Okay? And if they are the same line, then that means that they share an infinite number of solutions, or all solutions. All right, so now what does that solution look like? Well, that solution is going to be a coordinate, an xy coordinate. In this case, it will not be an xy coordinate because it won't work, and this would just be every coordinate that's on the line. Okay? So one of the things I want to say, which I'm trying to lead up to, and I didn't do that very gracefully, but write this down, any point, you writing this down, Megan? Any point on a graph is the solution to the equation. Very important concept. That's why I wrote it so big and bold, okay? So any point on a graph is a solution to the equation. Any point on the graph is a solution to the equation. So if we happen to have a point that lies on both of these graphs, then it's a solution for both of those equations. So that's one of your quests when you're solving these systems of equations. So Megan, when they ask you to solve by graphing, turns out that there's 3 different ways. I'm not sure if you're working on all 3 yet. Look at me. One of them is graphing, one of them is substitution, and one of them is elimination. Okay? And hopefully, if we don't get another example, I'll go ahead and bring those up. But if we're going to do graphing, let me warn you. Graphing is a very good technique, especially if the numbers work out pretty. Okay? The problem will be is that you know how sometimes graphs touch, but they're not touching exactly on the coordinates? Not the coordinates, but the grid lines. Then it's going to be a little bit trickier to figure out what the solution is. So one of the things I would recommend, now you've been specifically asked to solve this one by graphing, but graphing is good to estimate about where your answer will be sometimes, especially when those answers are a little uglier, if they're some intricate decimals or fractions. Not that we can't deal with those, but it's very difficult to graph those. So sometimes if you can just quickly graph the equations, you can see what quadrant the answer is in. If it's a multiple choice test, you might only have one answer that actually is in that quadrant. That might save you a little bit of time. Okay? So let's look at this graphing one. Now I've given you that big spiel. And let me go ahead and draw the system. Hopefully I've saved myself enough. Whoa, that was straight. Okay. And the first one says y equals 1/2 x plus 1. Megan, I hope at this point, and if you can do an xy chart. But what I'd like you to do is graph this using the y-intercept and slope. So the y-intercept is, or b is 1, so that means that the y-intercept is 0, 1. Y-intercept is a coordinate. So let's go to 0, 1. And then let's look at slope. Slope in this case is 1/2. If you recall, that's rise over run. We rise along the y-axis. We run along the x. So rise up 1, run 2, up 1, over 2, up 1, over 2. And let's get the other half. If we're going up 1 and to the right 2, the opposite of that would be to go down 1 to the left 2. Down 1 to the left 2. So if we draw that, let me get a piece of paper to make my straight edge real quick. Hold on. You guys always have a ruler. It doesn't have to be a real one, but if you have a piece of graph paper, you instantly have a ruler. Geometry people remember that because you don't get a ruler on the EOC. All right, so there's y equals 1/2 x plus 1. All right, so I did as pretty as I could. So let's use a different color, and let's graph this one. Again, I want you to use use the y-intercept and slope to solve this one. If you can't remember how to do that, I'd really like you to practice with that, Megan, but otherwise you can do an xy graph. So the y-intercept is a coordinate 0, 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. This is where it's going to be very important that you're very careful. Our slope is -3, or -3 over 1. So that's rise and run, remember? We rise, or in this case it's negative, so you can kind of say fall, right? So we're going to drop down 3 along the y-axis, and then we're going to run to the right on the x-axis once. So 1, 2, 3, 1. 1, 2, 3, 1. Look at that. Perfect. 1, 2, 3, 1. I'm going to go ahead and finish drawing it in, even though we've just found our answer. This right here, this point right here, which is 2 over 2 up 2, the coordinate 2, 2, is the common solution, or the solution to this system of equations. Y equals -3x plus 8. Look at that. So this was a nice one, Megan. Look at me. This was a nice one because the answers really turned out pretty. But imagine if the answer was 2.2 and 3.7, or it'd be kind of hard to see on a graph. But it would let you know that it was in that first quadrant, okay? All right, I hope that helps. Let's see if I have any others we can work on. All right, let's look at a substitution problem. Megan, keep watching if you're not there, otherwise get some of your classmates. Substitution is the next method. Okay. Now, what is substitution? Literally, we come back. What happens in a basketball game when you hear it? Substitution, right? Player 15 goes in for player 37, or whatever it might be. Every time you hear that buzzer, it's a substitution. So you're literally taking one player and putting them in the same position as another player. And the hope is that they are, that they have the same skills so they can keep playing just as if they'd never left, correct? All right, well, that's what's happening with substitution. You have two equations that let me take that back. You have two equations. In this case, they're going to be two equations that happen to have an x and a y in them. They could have any two variables in them, or any variables. But the variables that are in the first equation and the variables that are in the second equation, if they're the same letter, then they are the same number, okay? So if you're given the same problem, I don't care if you're given 10 equations with 20 variables in it, those 10 equations, if they've been all grouped together in the same question, all the variables are the same, okay? So when I look at this problem down here, now you can look at my screen. If I look at this problem down here, it says y equals -4x plus 8 and y equals x plus 7. The x and the y in both of these are the same. And I know you probably know that, but I want to emphasize that because that's the idea behind substitution. See how the first equation, y equals -4x plus 8, and y equals x plus 7? If I was to give you $1 million, look at me. If I was to give you $1 million and a $1 million suitcase, and there's two suitcases, and I said this one has $1,000 bills, and the suitcase on the left has $100 bills, would you care which one you picked? Because you're going to get $1 million either way. They're both equal to each other. So you could replace one with the other, and you wouldn't even know it, right? As long as you get to walk away with that suitcase. All right, so over here on our problem, that's what's happening. Y is equal to two different things. So two things equal to the same thing are equal to each other. So this is one method of substitution where you can take the two equations and just set them equal to each other now because they both equal y. So now you're at the point where you can go ahead and solve this equation. So I'm going to add 4x to both sides. That leaves me with 5x plus 7 equals 8. And I'm going to subtract 7 from both sides. That leaves me with 5x equals 1. So x equals, divide both sides by 5, sorry. X equals 1/5. All right? Okay. So 1/5, and if you'd done that in your calculator, you would have come up with 0.2, which is fine. So now that you know what x is, well, look over here. You have two equations that say y equals x plus 7, y equals -4x plus 8. So you know what x is, so substitute the value back into one of these equations and solve for y. You know which one I'm going to pick? I'm going to pick the second one. And the reason I'm picking the second one, now you could pick either one you want to, but this one looks simpler. And really, that is the logic behind it. Okay? Try to pick the simplest one that you could substitute back in. Or if this fraction had been more like a 1/4, then this first equation wouldn't look so scary because I would have canceled out some of my denominators. So if I substitute that in, y equals, here's our x, 1/5 plus 7. So y equals, well, if you ate 1/5 of a pizza and 7 pizzas, that would be 7 1/5. Or that's also equal to 36/5, or it's also equal to, what, 7.2. Either one works. Look at if this happened to be on the EOC, you're going to want to see which form they come in, or which form the answers come in, so you can make sure you have the right answer. All right, let's do another substitution, which is similar but not quite the same. If you can see that or not. Okay, now you can see it. All right, so 3y plus 2x equals 4, and negative 6x plus y equals negative 7. Now this one isn't set up as pretty as the other one, is it? That you don't know that both of them are set equal to y, and you've got a lot more numbers going on here, so, all right, don't panic. This is actually one that's very nice to do with substitution too, because you see how the y in the second equation is just all by itself? The coefficient is 1. That means it would be very easy for us to solve for y here, wouldn't it? All right, so if we leave equation 1 alone, but in the second equation solve for y, so that means I'm going to add 6x to both sides. I'm left with y equals 6x minus 7. Well, remember I told you that the x and the y in both of these equations are the same? So what if I took y equals 6x minus 7, and everywhere I saw y in the first equation, I put 6x minus 7. Substitution. So there we go. 3, and it's supposed to be a y, but our new y is what? 6x minus 7 plus 2x equals 4. Now you can go ahead and solve. What do we have to do? We have to distribute, then put like terms together, and then solve for our x. So distribute, we're left with 18x. 3 times negative 7 would be negative 21, plus 2x equals 4. We combine our like terms. We have 20x minus 21 equals 4. Let's add 21 to both sides. We're left with 20x equals 25. Divide both sides by 20. We're left with x equals 25/20, which is, well, you need to reduce that, 5/4. And hopefully you all are starting to leave your answers. Double check with what your teacher wants. But leaving an answer as 5/4, and you're off the screen, 5/4, that's okay, all right? If you wanted to convert that, you could. 4 divided into 5 or 5.0, you work it along. But this is a good answer, okay? So now that we know what x is, what can we do? Well, we know that y equals 6x minus 7, so substitute in our value for x, and we can find it. Y equals 6 times 5 over 4 minus 7. I'm going to put that over 1 just so I can see that real pretty. Now, you're probably typing that into your calculator. That's okay, but you know what? You can handle those fractions, by the way. So y equals 2 goes into 4 2 times, 2 goes into 6 3 times, so 15 halves minus 7. Pop that in, so y equals 1/2. Because 7, we could say 15 halves minus 14 halves, right? 15 minus 14 is 1/2. I'm just letting you know, because sometimes you get so dependent on that calculator that you forget that you can do some of the simple arithmetic. And if you were given a situation, your calculator broke, or you're in a situation where you can't use a calculator, then there it is, okay? You can remember how to do that. Not to mention algebra, you need to remember how to do some of these fraction things. Look at me. You need to remember how to do some of your simple fractions and simple, combining of your terms, because as you go a little bit further on, you know what, that's just going to come back. You're going to have rational expressions. What did I say rational numbers were? Numbers that can be expressed as fractions, basically. So you're going to have fractions that are just all variables. And if you can't remember how to take 15 halves minus 7, then how are you ever going to take 2x minus 4 over y, plus 7 over y, okay? So you can do this. You just have to remember some of those rules. So practice them anytime you have time to practice them. All right, so what was the answer to this one? Well, all of these, and I was being pretty bad about that. All of these, the answer is a coordinate. I mentioned that to you before. There we go. So it would be 5/4, 1/2. That's the coordinate. That's the point where the two graphs meet. And then that last one I did, I should have said the answer was 1/5 and 36/5. There we go, a coordinate. That's the solution. It's not just some random x and y. All right, so when I have time, I'm going to come back and do an elimination, but I heard we got a call. Did we get a call? It was a hang-up. Okay, so I am going to do an elimination, and this will finish up part of that unit for you all. Now, I believe a test is coming up maybe the end of this week, so this is good. So call me if you have a question. The number should be along the bottom of the screen, right? Otherwise, the number is 217-2203. All right. Let's look at this. What is elimination? Well, what is elimination? Have you ever played elimination in basketball where whoever gets the basket in first and the other person is eliminated from the game or taken out of the game? All right, elimination is that sort of thing where we have these variables. In this case, I'm going to be working with variables x and y again, and that's what you're used to. They could be other variables, so don't panic if other variables show up. But we have our variables x and y, and the x and y in both equations are the same. We're going to eliminate one of those variables. Do anything we can algebraically to eliminate one of the variables so that we can just solve for the one that's left, okay? So it's very similar to substitution in that you're going to be dealing with just one variable, but we're going to actually do some math to eliminate. So there's 3 different situations that might pop up. Let's look at this first one, okay? The first one, I have 5x minus 6y equals negative 32, and I have 3x plus 6y equals 48. So in elimination, one of the things you're going to be doing is you're going to add or subtract the 2 equations together. Your goal is to eliminate one of the variables when you get that final sum or final difference. So if I was to add these 2 equations together right now, I'd get 5x plus 3x is 8x. Negative 6y plus positive 6y is 0y. Look at that. The y has been eliminated. And then negative 32 plus 48 leaves us with 16. Divide both sides by 8. We're left with x equals 2. Look how quick that simplified. Now, if we were to do a substitution on this one, it would be very ugly because, see, how did I do with that last one? See them next to each other. See how in this, the one I just did a moment ago, the y had the coefficient of 1. So when we solved for y, it was a pretty equation, y equals 6x minus 7. That's not real scary to deal with. If I was to do the same thing with this, one of these equations and solve for y, let's just take this first one and solve for y. I'd get negative 6y equals negative 5x minus 32. Divide everything by negative 6. I'd get y equals positive 5, 6x plus 32, 6, which would have to be reduced. But then you want to take that and substitute it into the second one. Okay. I'm not saying academically and mathematically you couldn't do that, but that is just not a pretty situation. Elimination, very nice, okay? Add the 2 equations, eliminate one of the variables. So now we know that x equals 2, so what can we do? Substitute that back up into either one of them to solve for the y. Now, which one am I going to choose? Well, believe it or not, I'm going to choose the second one. Why? Because there's not as many negatives in the second one. That's my rationale. I know when I have, look at me, I know when I have fractions in an equation versus one that doesn't have fractions, I'm going to choose the one without fractions. If I have an equation that has a lot of negatives and another one that doesn't have a lot of negatives, I'm going to choose the one without negatives. If I have one that has really big numbers or really small numbers, I'm probably going to pick the really small numbers. You're going to have to practice with these enough that you know which equations feels most comfortable to you. The neat part about this is that regardless of which equation you pick, you're going to get the same answer, okay? So it's kind of personal preference, or as you practice with it, you'll start to see some trends and some, again, if these answers had been fractions, you want to look for, say, denominators that might cancel each other out and simplify the equation much faster, okay? All right, so let's substitute in x. We'll put it into the second one, so 3 times 2 plus 6y equals 48. Ooh, that's a big 8. So 6 plus 6y equals 48. Subtract 6 from both sides. I'm left with 6y equals 42. Divide both sides by 6. I'm left with y equals 7. So my solution is 2, 7. Very nice. And again, what does that represent? That represents a point of intersection. Okay? If these equations represented 2 planes, you better hope that the, what do they call that person up in the tower? Whoever the people in the tower, I can't think what their name is. Controller people in the tower, there you go. All right, they'll shift the elevation of the plane so that we don't get that intersection. All right, let's look at the second one. Second one says 2x plus 5y equals negative 22, and 10x plus 3y equals 22. Should we do a call first, or I'll go ahead and keep going with this one? All right, I'm going to keep going. All right, so let's look at this one. If I was to add these 2 equations together right now, I would get 2x plus 10x is 12x, plus 5y plus 3y would be 8y, and negative 22 plus 22 equals 0. Have we gotten any further with this new equation in solving for a variable? No. Okay. Oh, let's subtract them. Okay, let's subtract. That works. 2x minus 10x leaves us with negative 8x. 5y minus 5y minus 3y gives us positive 2y, and negative 22 minus positive 22 gives us negative 44. Oh, that's much better. No, it's not helping. Okay? This is a situation where when we added and subtracted, the variables didn't disappear. So now, or I shouldn't have said disappear. One of the variables did not eliminate. All right, so what do we need to do? Well, the fun part about algebra, look at me. Fun part about algebra, I think, is that you can manipulate an equation to be anything you want to. If you're sitting there and you're really bored and you're like, you know what I would really like to do? I would like to multiply both sides of the equation by 2. Guess what? In algebra, you can. There's a property, I guess, the multiplication property of equality that says if A equals B, and then AC times AB or BC equals the same thing. You're allowed to do that. There's even a law that says you can do that. What if you wanted to divide both sides by 3.7? Nobody's watching, you can do it. In fact, even if somebody's watching, you can do it. That's the cool part about algebra. You can do whatever you want to, as long as what? You do it to both sides. You have to keep the equations balanced. Okay, so let's look at these two equations again. I'd like to add them together. Why do I want to add? I like addition better than subtraction. If I had to sit there for 10 years and I had to choose whether I was going to do addition or subtraction, I would choose addition. Why? Because that's what I like better. If you would like to subtract them, you can. I think addition eliminates some of the errors with your negative, but it's your choice, but I'm going to add in this one. All right, if looking at these, I want to try to eliminate one of them. So is there anything I could do to the first equation? Or is there anything I could do to the second equation so that the coefficients of either one of the variables match up? Okay, so they're the same. Let's look at x, 2x and 10x. If I could take the first equation, or this 2, and multiply it by 5, wouldn't the 10s match? Sure would. In the second equation, I have 5 and 3. I would have to multiply the top one by 3 and the bottom one by 2. So that's 2 steps. So I think I'm going to be lazier about it and choose the 1 step. But now if I just multiply it by 5, what happens? I have 10x. 10x plus 10x. Well, that's 20x. That didn't help me. So what if I multiply by negative 5? That'll work. All right, so I'm going to rewrite the second equation down below. So that leaves me with negative 10x plus negative 25y equals positive 110. Thank you. And I didn't do anything to the second equation, so I'm just going to rewrite that down below it. So 10x plus 3y equals positive 22. Is that up here somewhere? So now what can I do? I'm going to add these. So negative 10x plus 10x, look at that, eliminated 0x. They've been eliminated. Negative 25y plus 3y is negative 22y equals 110 plus 22 is 132. Let's divide both sides by negative 22. We're left with y equals negative 6. Beautiful. Okay? That is very nice. So now that we know that y is negative 6, what can we do? We can take that and substitute it back into one of the equations. I'm going to choose the first equation. Why? Because the last two examples I chose the second equation. Okay, so maybe that's a reason. And look at this. 2 is smaller than 10. There's a good reason. All right, so 2 times, it's x, so we put that in for y. Sorry about that. So 2, let's try that again. 2x plus 5 times our y, which is negative 6, equals negative 22. Now we can go ahead and solve for our y, our x. So 2x minus 5 times negative 6 is negative 30, equals negative 22. Let's add 30 to both sides. I'm left with 2x equals 8. Divide by 2, we're left with x equals 4. Beautiful, beautiful, beautiful. What is our final answer? 4, negative 6. Now, would this have been a nice one to do for graphing? It sure would. Oh, you're back. Hello. It sure would have been a nice one because the answer turned out pretty, but the original equations were in standard form, And not that you can't graph from standard form, but a lot of you would manipulate that so that you would put it into y equals mx plus b form, and you got that slope and that y-intercept. So it would have taken you a lot more steps. So even though this would have been a nice one to do in terms of a pretty answer, or the pretty coordinate of what was it, 4, -6, it was kind of awkward to start off with because you didn't see that right away. All right. Is there a question? All right, I have one more elimination that I want to show you, but I'm going to come back to that so we can answer this question. We have Brett from Southeast Raleigh High School. Hi, Brett. This one is find the coordinates of the point of intersection of the medians of CD and BE for triangle, let's make sure it's all on the screen for you. There we go. For triangle ABC, if A equals 4, -5, B equals 8, 11, and C equals 0, 15. Oh my goodness. This is a good one, Brett. First thing we need to do is understand the problem. I hope that the very first thing you do is take a piece of graph paper, which I'm trying to get off to the side, that's why I'm still talking and stalling because it's stuck. There we go. Take a piece of graph paper and graph your A, B, and your C, so you can try to get a visual of what's going on here. All right, so let me go ahead and do that. I don't go over very far, so let's do that one, but I need a lot of height on this one, don't I? All right, hopefully that works. All right, so our A was the point 4, -5. So over 4, 1, 2, 3, 4, down -5, 1, 2, 3, 4, 5. There's A. B is 8, 11, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. There's B. And C is 0, 15, 0. 1, 2, 3, oops, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. All right, so we have that. I'm going to go ahead and draw the triangle so I can visualize it, because they're asking for a lot of things on this. And even though this is coming from a geometry class, Algebra 1 and Algebra 2, this is something you definitely want to pay attention to. Even 8th grade, you guys have been writing equations, and this problem is about writing equations. Okay? Just because there's a triangle in there and there's some other vocabulary doesn't mean you can't do it. All right, so find the coordinates of the point of intersection of the medians of CD, or the median CD. So that means a median. What's a median? Brett, what's a median? I'm not sure if you got that right or not because I couldn't hear you. Speak up, Brett. Teasing. Okay, median. Median, middle. It's going to go from a vertex to a midpoint. From a vertex to its midpoint on the other side, okay? It doesn't have to drop straight down. It doesn't necessarily have to be perpendicular. It just has to go from a vertex to the midpoint of the other side. Midpoint, median. So there's some important concepts. So CD is going to be starting from C, and it's going to be going to the midpoint of AB. What is the midpoint of AD? Well, it's going to be D. So we don't know that yet. So list of things that we need to do. We need to find the midpoint of AB, and that'll give us this line. I don't want to draw it in there because I don't want it to be there. It's going to be somewhere around in there. And then we need to find the median of BE. So that means it starts at B, and it's going to go over here somewhere, about the midpoint. So we also have to find the midpoint of AC. All right, so once you have the midpoint of AB and AC, then we're going to have to be finding the equation of the line. So what are some things that we're going to need to find the equation of a line? Well, to find the equation of a line, you're going to need a point. Well, we have points. We have our point C, we have our point A, and we'll have our midpoints. You're also going to need slope. So something else we're going to need to do is we're going to need to find the slope of CD. So that's the equation we're looking for. And the slope of BE. All right, once we have slope, then we'll have to actually write the equations of the line. So we'll need the equation of CD and the equation of BE. And once we have two equations, we want to know what is the intersection. Well, if you were paying attention a second ago, one of the things we just talked about, there we go, there's the list of things I'm looking for. The intersection right here intersection is basically a system of equations, right? So if I have two equations, I'm going to be using systems of equations somehow. Remember, I can do that by graphing, substitution, elimination. This was a good call, Brett. This worked right in. To find the intersection of CD and where it intersects with BE. And we know that'll be a point somewhere, right? And that is actually the answer that we're looking for. So this is a 1, 2, 3, 4, 5, 6, 7-step problem. Okay? Not too bad, not too bad. You can do it as long as you remember all your parts. Okay? So I'm going to put my little checklist off to the side. Can we see the checklist? Well, I'm going to kind of go back and forth. So the first thing, midpoint of AB. Where's some plain paper? Hold on. Oh, duh, right here. So the midpoint of AB, let me just outline what would be equation for midpoint. The midpoint of some xy. Midpoint of some xy is basically the sum of the x coordinates divided by 2, sum of the y coordinates divided by 2. What is that? The average, the middle point, the average, okay? It's basically what you're doing. You're finding the average of the coordinates. The other thing we're going to be looking for is slope. Slope is what? Rise over run. Rise of what? Well, it's how much you started at one point and rose to the other one. So it's the change in the y coordinates over the change in the x coordinates. Some of you are going to see that written, and I probably should write this one out, but you'll see it as y2 minus y1 over x2 minus x1. Does that ring a bell? I'd much prefer that you learn how to do it this way, and I bet your teachers would also. It's much easier for you to know what the concept is than just try to find a formula. Over here, you might be saying x2 plus x1 divided by 2, y2 plus y1 divided by 2, an average. And look, it's a coordinate. Then we're going to have to be I don't know why I keep doing that. Then we're going to have to find the equation of a line. Equation of a line given a point and slope means we're going to use point-slope form, which would be y minus the y coordinate equals slope times x minus the x coordinate. And then finally, we're going to have to do systems of equations, which we're not quite sure which method we're going to choose. So there's all my recipes. I've got all my ingredients. Here's the coordinates. So now I can start doing some of this footwork, okay? So first, the midpoint of AB, which would be D. That coordinate is going to be 4 plus 8. I don't know if you can see. There we go. I'm using these coordinates right here, correct? So 4 plus 8 over 2. And the other one's going to be negative 5 plus 11 divided by 2, which leaves us with the coordinate 6, 3. So if we look at our graph over here, 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. So now we have the median, CD. Oop. Next, we need to find the midpoint of AC, which was E. So that's 4 plus 0. I've lost the coordinates now. Hold on. Ha! I know what we can do. You could say you could just rewrite them, Ms. Richardson. No, that would be no fun. Let me separate the problem from my work real quick. In class, I would actually cut the overhead. It scares people. All right, so there we go. All right, so we're going to use our points now. So that would be 4 plus 0 divided by 2. Negative 5 plus 15 divided by 2. Leaves us with 2, 5. All right, so there's our midpoints. Now, how would we find slope? We need the slope of CD, okay, which would be 15 minus 3. 15 minus 3 coming from this coordinate right here. All right, so we're trying to find the mid-slope of CD. So 15 minus 3 over 0 minus 6, which leaves us with 12 over negative 6, which is negative 2. So the slope of CD is negative 2. Next, we're going to have to find the slope of BE, just looking at my checklist. So I'm going to use B and E right here. This was D. This is E. So that leaves us with 11 minus 5 over 8 minus 2. which leaves us with 6 over 6, which is 1. So the slope of BE is 1. So now we can actually write the equation of the line. Let me grab another piece of paper for you real quick. All right, hang in there. All right, so let's see where we are now. I have E. I forgot to plot E for you. So 1, 2, 1, 2, 3, 5. So what are we looking for? We're looking for that point. Now, if you were really pressed for time, that looks pretty. The more accurate you are, but you know what? I don't know if I would. This is a really if you're given this problem on a test, this would pretty much encompass your whole chapter, so that you wouldn't want to get any part of this wrong. So the next thing, we have these pieces. I want to be sure you can see it. I want to stay on my screen. All right, so the next thing is we have to find the equation of CD. All right, so for the equation of CD, what do we need? The equation of CD, we need the slope. The slope of CD, we just found a second ago to be -2. And we need a point. Well, CD, we have 2 points. The point C was 0, 15, and point D was 6, 3. I'm going to choose 0, 15. You know why? Because that is already the x-intercept, or the y-intercept, right? Over here. So that makes it actually pretty nice. We don't even have to do point slope form. We can just say y equals mx plus b. 15 is our y-intercept, so y equals m, slope, -2x plus 15. Now, if you'd chosen the other coordinate, you still would have gotten there. So there's the equation of CD. Now we have to find the equation of BE. So we need 2 pieces of information. We need slope of BE, and we need a point on BE. So the slope of BE we found a second ago to be 1. That's nice. A point on BE where you can choose point B, which is 8, 11, or you can choose point E, which is 2, 5. I'm going to choose 2, 5 because it's smaller. The numbers are perhaps easier to work with. We'll know in a minute. I have a point and I have slope, so we're going to use point slope form. So y minus the y coordinate, 5, equals slope, 1, times x minus the x coordinate, which is 2. Nice. So y minus 5 equals x minus 2. Add 5 to both sides. We're left with y equals x plus 3. So there's our 2 equations. Ha! We are not done. Now, we have the equations of these 2 lines. Now we're trying to find the point of intersection. Point of intersection, we're going to use a system of equations. So looking at these 2, I have y equals -2x plus 15, and I have y equals x plus 3. Since it's geometry, we'll look at transitive. If A equals B and B equals C, then A equals C, right? 2 things equal to the same thing are equal to each other, or substitution. -2x. You had to be paying attention to the last problem to understand why I just did that. Equals x plus 3. Let's solve. So if we solve, I'm going to add 2x to both sides. I'm left with 15 equals 3x plus 3. Subtract 3 from both sides. I'm left with 3x equals positive 12. Divide both sides by 3. I'm left with x equals 4. Now that I know what x is, I can substitute into one of these to find out what y is. If y equals x plus 3, then doesn't y equals 4 plus 3, which is y equals 7. So the answer is, dun dun, 4, 7. Let's see how close we were. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Check. Whew. Brett, I hope that was not some question on a test. That is a great question. If I was a teacher, I would love to give that question on a test because it's everything. It's all right there. Okay? The only problem would be is that if you got any part of it wrong, you're going to you might have some errors. So show your work. Okay? Find out what your teacher wants. Great problem. I hope that helps. It should have helped all of you, right? Helped geometry. It helped algebra. All right, we got a call. Algebra 2 from Nivea. Mr. Rosa's class at Southeast Simplify. Simplify. Now we're working with radicals, it looks like. Oh, you're gone already. Working with radicals. Come back. You're working with radicals right now. Radicals, don't be scared, okay? Radicals are just another number, and sometimes, if you treat them similar to variables, you might be able to simplify them easier, okay? So the problem that it looks like we're about to do, and don't go back yet, the problem it looks like we're going to do is two parentheses that are being multiplied with two numbers in them. What do we call those? Binomials. Okay, so what did you do when you had a binomial times a binomial? What do you wrap up chicken in? What do you wrap up chicken when you're going to put it in the refrigerator after you've eaten? Tin foil, that's it. You're going to foil, right? And then, it's coming from a restaurant, you might put it in a box. Yes, you could do the box method, whatever works for you. So just because the numbers have changed, the patterns haven't changed. It's still two binomials, kind of a double distribution, right? FOIL method. All right, so let's look at this one. And I know you're thinking, oh, Algebra 2, I don't know how to do that. But you know what happens is sometimes you see this and you start adding things together and you panic. Treat these just as if they were x's and y's, just variables. Then deal with the simplification a little bit lower in the problem. All right, so first, square root of 5 times the square root of 5 is the square root of 25. Square root of 5 times square root of 15 is the square, minus square root of 75. Square root of negative 2 radical 15 times square root of 15 would be negative 2 radical 75. And negative 2 radical 15 times radical 15 would be negative 2 times radical 225. Okay? So I just did the math. Now let's go back and simplify. Square root of 25 is 5 minus radical 75 minus 2. There's a 1 right there, right? So negative 1 radical 75 minus negative 2 radical 75. What if those were variables? That'd be like negative 1x minus 2x. What is that? Negative 3x. Okay, so negative 3 radical 75. I still have to simplify that. I know that just because I am familiar with my numbers. But you always want to go back and be sure that things are simplified as far as they can go. So took care of those two. Minus 2. Now, what's the square root of 225? Good, 15. You should know those perfect squares, I would say at least up to 20. Okay? So we have 5 minus, now what are we going to do with 75? 75 breaks down to be 25 times 3, which is 5 times 5, right? There's a couple, pull them out. So that's 3 times 5 times radical 3. So that's 15 radical 3. Did I mess something up? Oh, it was a plus? Where? Oh, it was a plus. So I should have what? A 1? 1, negative 1. See? Here I am talking to you guys about how trivial the arithmetic is, and I went and made the same error. So watch your signs. And you know what? To be honest with you, I would have done this one in a box, and maybe I'll set it up that way. Because whenever the numbers look a little bit more awkward, sometimes I like to make it, and I know my handwriting, I try to make things as simple as possible, and the box would have done it for me. So let's keep going. So 15, so there's no 3 there. So that would have been a 1. Let's backtrack. We're okay. 5. So 5 radical 3. Now I'm good. Minus, and then 2 times 15 would be 30. Whew, let's get back on track. All right, so now what do? We have 5 minus 5 radical 3. Can you combine those? Don't be tempted. That's the same as saying something like 5 minus 5x. Those are not similar terms. You cannot put them together at this point or combine them at this point. But 5 minus 30 we can, so that's negative 25 minus 5 radical 3. Okay? Now, just to show you what I would have done, what I honestly should have done, I know my handwriting. I know what works best for me. This is the same thing, but now it's very neat with the radicals, and I can pick out my signs. So whatever method works for you, it's the same exact process, just a different procedure. All right? Oh, raise it up. There's the box, okay? Wonderful. All right, great problem, Nivea. I hope that helped. I hope I didn't confuse you more. But treat these just like variables. This is no different than doing the FOIL method like you would do if you had a regular, well, it's not regular, if you had a binomial with variables. Okay? All right. We are out of time. Oh my gosh, I'm sitting here going on and on. All right, I didn't have time to do the final elimination one. I just want to show you real quick. Come back. Here, and the answer's already there, but this final elimination one I wanted to show you. See how this is 4x, woo! 4x plus 2y equals 14 and 7x minus 3y equals 8. For 4 and 7 to have a number that's the same, for the x's to have a coefficient that's the same, I'd have to multiply the top by 7 and the bottom by 4. And for the y's to eliminate, I'd have to multiply the top by 3 and the bottom by 2. So sometimes you're going to have to do that to the same, both equations. You're going to have to manipulate them. Don't panic. Just keep tweaking them until you can eliminate one of those variables. All right, well, that's all the time we have. I hope you guys had a good time calling in with your questions. Don't forget to email, and now we're live on the web, so you don't even have to be near the TV, okay? Just give me a call, and I will see you I'm going to see you next Tuesday and Thursday, and I'm going to try to focus a little bit on some of the EOG questions that are coming up for middle school. But high school, you can still come in with your questions, all right? All right, so see you next Tuesday and Thursday, 4 to 5. Bye. Clarissa. How did Clarissa become Nivea?